Hello! Today we're going to be talking about fur color and fair chance. We're testing the assumption, do pets with black fur wait longer at shelters than ones with not black fur? So first we're going to start with 4 steps. We're defining the problem, analyzing the data, testing the hypothesis, then drawing a conclusion. Let's start with defining the problem. So does coloration affect adoption in animals, and do pets with black fur take longer to adopt? The purpose of this is to understand the aesthetics and bias of pet adoption and how rescues can help less likely pets to be adopted. Let's define a couple things first. So our sample is 8,000 pets that were adopted between 2006 and 2019. Our population are all the pets taken into this one shelter that were logged. And our statistic is the average days that it takes to get adopted based on coat color, while our parameter is the average color variation for all animals in the shelter. Qualitative variable is the color of the animal, while quantitative variable is the number of days in the shelter. Let's analyze this data now. So first, our initial table. Some of it's not so useful, and some of it's not defined. As such, we're going to focus on the color and day stayed. So once we get the clean table, we've gone through a little bit here. We have a couple tables that we can use for different purposes. Our first table is the adoptable clean, our large data set, and it's useful for later computation and testing permutation. Our second one is average days with counts. This is a simplified data set useful for more visual charts and at-a-glance reference. Let's do a few initial analyses. For our data types, we kept it simple, one of each, both an integer and a string, and then we're also using a Boolean comparison to add another column to our simplified table, giving us the number of pets with that value for that color. Let's talk about mean, median, and standard deviation and what those mean for this data set. So for our mean, on average, all animals took about 856 days to be adopted. It seems rather high, so let's also look at median. Our median is only about 393 days, which is still high at over 1 year, but it is a lot lower than our mean, which gives us some data there. It suggests that there is a group of animals that took much longer to be adopted, and our standard deviation supports that. We have a high standard deviation at 1,103 days, which suggests a lot of variability. That does also mean that we can potentially assume it will be difficult to come to a true conclusion due to this volatility. So let's look at our first chart, our histogram. So we're understanding we're going to see a lot of variation. Our standard deviation told us that. But we can clearly see here that while a lot of our animals are adopted in under 1,200 days, about 3.4 years, there's a portion that took just under 5.5 years to be adopted, or 2,000 days. Our scatter plot is similar to our histogram. We're looking at the number of pets that took over 365 days to adopt, and we see, as expected, a fairly straight line, thankfully with most of them at closer to the 0. This suggests that the more pets in the shelter, they maintain a similar ratio that take over 1 year to adopt. Fun, not so fun fact, the outlier point all the way to the right with over 2,000 pets and over 1,000 days are the black-furred pets. Let's review the bar chart for our top most populated fur colorations with average days in shelter. So this is the most numerous pets for fur color and the top 10. With this chart, our assumption that animals with black fur take longer, it does not seem accurate. It is not the top one here. That actually belongs to the brown brindle. So just based off this chart, we don't seem to be trusting in that one just yet. But let's see if anything changes. For our user-defined functions that help us manipulate the data, we had 2 here. We had black or non-black, that helps with A/B testing and future hypothesis testing. And then we also had a classify stay, and that adds another easy reference point by using if statements to categorize the type of stay. if it was short, medium, or long. Let's finally test the hypothesis. So far, like I said, it doesn't appear that fur coloration affects adoption, but what do the statistics say? First, let's define the hypotheses. So for null hypotheses, there is no difference in adoption time between black-colored animals and non-black animals. Any observed difference is due to random chance. Our alternative is that animals with black fur take longer, as we've been talking about. So, we're looking to see if animal coloration affects the days it takes to adopt. Our cutoff is defined as 0.05. Utilizing shuffling through sampling our generated histogram for visual, as you can see to the right here, we then find our p-value. Our p-value, 0.24. And based on just this, it strongly suggests we cannot reject the null hypothesis with this data. It looks like it's random chance, but let's see what our confidence interval is, our CI. So we range from -37 to 81 days. 0 falls well within that range, so we can't actually say that animals with black fur take longer to be adopted. It may just be due to chance. So, finally, let's draw the conclusion. We cannot reject the null hypothesis in this particular study. However, we also did find fur color does not appear to directly affect adoption timing, at least not based on what we looked at here. Animals with black fur had almost twice the number of pets in shelter as the next common fur color, and a median stay at the shelter is over 1 year. So, in conclusion, we don't reject the null, so we take the null, but the bigger point to all of this, I think, is adopt, don't chop.